Howdy, welcome to our Brlcad DevCon presentation for CSCE482 Senior Design Capstone Project, with Dr. Wade as our professor and Sean Morrison as our client stakeholder.
Hi, I'm from Great Garza. I was in charge of scope management, and I'm going to introduce us as a team for you. We have Isaac Yang on stakeholder management, Danny Parego on risks and challenges, Ivan Perez on quality, and Yushi Lin on schedule management.
For our project, we are using Brlcad, which is an open source CAD modeling system and specializes in vulnerability analysis. At the moment, there is no defined or holistic way to catch errors relating to the verification and validation of the geometry being laid out, which can make it difficult to identify the purpose of the downloaded geometry or to know its purpose. There needs to be addressed and integrating with the current system, a system where a verification and validation measure can be found, as the process to repurpose it can be time-consuming and expensive. Our solution is to embed the verification and validation functionality into the existing Arbalest application, which includes giving the user the ability to run customizable batch tests and parse their outputs and display it to the user. Some of the requirements would include a system that automates laborious checks, an intuitive design, and for it to be cross-platform.
Yeah, so talking about like the methods and designs, we can see that, we use the agile methodology. Basically, we had a bunch of user stories, which really is just like a bunch of tasks for us to do each week. And we assigned these tasks, for every week to each of us developers. And we created a minimum viable product at the end of each sprint. And, of course, we iterated based on feedback. So that means like whenever we did user acceptance testing or, internal testing or, maybe just some feedback from Sean, then we would go in and make some new stories and iterate and change our product based on feedback. So.
Okay, a little more about design. We built our project on top of Arbalest, and it supports verification and validation of visible objects. It also supports custom selection and running of tests and multi-threading. And the users are able to add or remove tests and test suites. And there's a feature with embedded mget terminal for the user to modify CAD files without opening another program. And the project also parse and the terminal output and display them in a table for the users to visualize the problematic objects easier.
On to our database or data design, we chose a database rather than storing just in files. And we did that for the reason that most of the information we're going to be storing could generate thousands of rows in a table. And we want to be able to very quickly and efficiently sort through that information, as well as it gives us the advantage of not having to write custom code in order to go through that information. Our database stores information like what tests we have the ability to run or might have been created by a user, and information about that test. Also information about test suites, information about models, information about the results we got from a given run of tests and what kind of issues they have, what objects those issues belong to, different information like that. Next slide, please.
Hey everybody, my name is Isaac and I'm from the Texas A&M Brlcad team, and this is our project demo. So what we have right now is the Arbalest app, and essentially it allows us to kind of view the wireframe of a given model and do some ray tracing. But what we went ahead and implemented is the ability to verify and validate any of these models. And so by clicking on the top right hammer icon, we can verify and validate and choose the test we kind of want to run. And each of these tests just tell us a little bit of a different thing about the model. Like, for example, does it have a good title? Are there any nested regions? Are there any empty combos? And so the modeler is able to, pick up information like this automatically before actually shipping it off to production for manufacturing and things like that. Another thing the modeler is able to do is actually modify some of these parameters. So, by modifying some of these parameters, they're able to get some different behaviors and different things about the project or about the model. And so, but, by going ahead and actually running the test, we can kind of see our progress bar populate as well as our result table. And we see different issues going on with our model. So we can just kind of see the no nested regions issue, which, we can actually get more details about by right-click more details. And, we can kind of see the commands, the result code, description, raw output, and things of this nature. And so this might be useful for the modeler if they're trying to debug something or pin something down. Another tool that they have is the ability to right-click visualize objects. And so, this no nested regions issue is due to this little cargo box R3i object. And, this is what has a nested region. So, another thing that they're able to do is right-click copy path, and essentially this gives the path of the problematic object. So they can use our embedded mget terminal to actually fix this in the model. And so, a more experienced modeler might actually be able to fix this issue. But for us, we can take a look at a more simple issue. And this would be the valid title issue. Essentially, the title has the word untitled in it. So this indicates that there should be a better name for the project. And so we can go ahead and rename it, and we should be able to rerun and get better results. So we went ahead and renamed the project. And if we go ahead and run the tests on only the valid title time, we can see that, okay, we detect that, there's been changes to the model and we see a little bit of more information, but this makes sense because we just changed the title of the project so that the file has also changed. So it's just a kind of a heads up to the modeler. But of course, now we see that it passes. And so now that we see it works for the shipping container, we just want to, kind of bring it through that this is a general solution. It doesn't just work on a cherry picked model file. We can actually, do it on something like Havoc, which is a much more complicated file. So, we're only going to run it on a little piece of Havoc just in the interest of time, as tests can take quite a while for large models. But we can go ahead and run it and see, okay, well, now we have all check marks. We don't have any issues. And so we're all good. And so, in order to supplement the features that we just talked about, like the terminal and all the tests and everything, we added some more features such as, the creation of new tests, which, in the case that a modeler wants to check out different properties of the model, they're able to add their own custom tests within this little dialog, and they're able to run these custom tests. So of course they can remove said tests and any of the other tests, and they can also create new test suites, which is more of like a categorization thing if they want to keep things neat. And they of course can remove said test suites.
So for our evaluation plan, we're mostly trying to ensure quality of the product and functionality. On the developer side, internal testing was managed by edge case testing, making sure that all the functionality is correct and making sure that any input can be handled from a user and can output gracefully. We also have unit testing for all of our parsers to make sure that no matter what input we're getting from a test command, that we can process that right and show that either it is passable output, errored, or unparsable. For user acceptance testing, we ended up using two different groups. The Texas A&M student group were evaluating our GUI, and our DoD modelers were evaluating the application more holistically, checking for correctness. For the most part, our feedback is positive, and all of our comments are mostly surrounding usability and intuitive design. For considerations or budgeting, we didn't end up having any budgeting issues. There was no cost to us, but for professional developers, we went ahead and made a cost estimate for what this would cost the company to do it with their own employees. 5 developers in Texas, the average salary for a software engineer would be $35 an hour. Each of us worked individually about 175 hours over the semester in a 12-week time frame. The Qt licenses for all of us combined would be about $900 a month. So the total cost ends up being about $33,000.
All right, so for engineering standards, so health and safety wise, missing an error could be critical to people's safety. So we need to make sure that all of the errors are being parsed correctly and displayed on the widget. And for manufacturability and sustainability wise, the project is cross-platform, means that it can run on Windows, Mac, and Linux, and produce high reproducibility. And there's no sustainability concerns, and it saves time and money.
That's it for our presentation. Thanks for watching.